Hello everybody. So today we are going to start with the first practical of our trimester for the subject of basic mechanical engineering. And since this being your first practical and since you all are new to mechanical engineering, so we'll have a little bit of overview of what is mechanical engineering and a little bit about what we are going to study today about, that is about the power transmitting elements. So in mechanical engineering you will come across different branches of engineering, like thermal engineering is there, which is related to the heat and transfer of heat. You will have subjects like thermodynamics, heat transfer, fluid mechanics. Then you will come across subjects related to design engineering, like strength of materials or design of machine elements. You will also come across a subject like manufacturing engineering, where you will study about different manufacturing processes, how the material is being converted into the finished product. So all these things you will be studying in your next 3-4 years of your BTech degree. So to begin with, today we will be talking about the power transmitting elements. So power transmitting elements are nothing but those elements or those devices which are used for transmission of power from one location to the other location. For example, let us consider an automobile vehicle which is running on engine, and engine produces the power. The power which is produced by the engine, it is in terms of rotational motion, rotary motion, and it is produced at the output of the engine. Now this power is required to be transmitted to the wheels on which the vehicle is moving. So this is one of the main functions of power transmitting elements, where power is transmitted from engine to the wheels. So this is one function. Secondly, the engine runs at a very high RPM, around 2000 RPM or 2000 to 3000 RPM. Now, if the wheel starts rotating at this high RPM, it will no more remain automobile vehicle. It will fly like a aeroplane then. So it is required not only to transmit the power, but you have to regulate that RPM, regulate or reduce or increase RPM depending on your requirements. So the second function of power transmitting elements is to reduce the RPM or to increase the RPM, both. Now one more function you can observe in power transmitting element. So let us consider one example of a bicycle. So what happens is there is human effort is required in bicycling, isn't it? So to reduce that human effort, power is transmitted from our pedaling wheel to the rear wheel of the bicycle. So you have there two elements called as a sprocket and a chain. So there are two sprockets. One sprocket is connected to your pedal, another sprocket is connected to the rear wheel. And these two sprockets, they are connected by element called as the chain. Now motion is transmitted from the pedals to the sprocket, and from that sprocket to the rear sprocket with the help of the chain. Now obviously the effort which you need will be very high if the sprockets are of same size. But you will find that the sprocket of rear wheel is smaller in size. That is because that is so that you need lesser effort for your cycling. So that is the third function of a power transmitting element. Your efforts are being reduced. Okay. There are many other functions also. You will be studying it in detail in your higher classes also. So today what we are going to discuss is about the different power transmitting elements which are used in automobile vehicles or other machines. Okay. So we have the most important, one of the most important and very common power transmitting element. It is called as a gear. Okay. So so this is something like a gear. Okay, this is called as a gear. Now in this gear you can see it is nothing but a disc which has a hole at the center. This hole, this is called as the hub actually, and on this face of the disc you have large number of teeth are there. Okay, actually these teeth are responsible for transmitting the power. Now you will have another gear attached to this, and power will be transmitted from one gear to the another gear, and so on like that. So we are going to study this in detail again. Okay, so this is one example of power transmitting element. Another example of power transmitting element is clutch. So here you can see this is the clutch. So in this clutch you have two discs are there. So there is one disc on the left side and this is the another disc on the right side. Now these two discs they are rotating independently. If one rotates, other will not rotate. Okay. Now when these two discs, when these two clutches or these two clutch plates, when they are in contact with each other, when they are engaged, then in that case power is transmitted from one clutch to the another clutch. Okay, so here you can see if I rotate the left hand side clutch, automatically the right hand side clutch also rotates. So power is transmitted from left side to the right side. Now the left side this clutch it is attached to one shaft and this right side clutch is attached to another shaft. So obviously power is transmitted from one shaft to the another shaft. Okay, that is one example of another example of power transmitting element we have seen. Now there is one more example that is called as a coupling. Coupling means it is attached, it is used for attaching two different shafts together so that power is transmitted from one shaft to the another shaft. Okay, so here you can see this is called as a muff coupling. This is called as muff coupling because you can see what you can see here, which is in white color, which is made of acrylic material here. That is called as a muff. Okay, so that is why it is called as a muff coupling. Now another example of a power transmitting element is a flange here. Now here you can see there are two flanges. Flange is nothing but a disc. It is a disc. Okay, so you can see the flanges. These flanges they have holes on their periphery. Now these two flanges are attached to two different shafts actually, and when we connect these two flanges and we bolt them together through these holes which are there on the periphery, then power is transmitted from left hand shaft to the right hand shaft again. So it is same like the clutch, but the difference is that once you connect the flanges you will have to unbolt all the nuts here and then only you can separate the two shafts, whereas in case of clutch it is very easy to disengage them. So when you need a permanent engagement, then in that case you can use flanges, and when you need a temporary engagement off and on, when you have to engage and disengage, then in that case clutches are used, and clutches you can see they are commonly used in automobile vehicles also. Okay. Now the third again next element which we are going to see, it is nothing but the bearing. Okay, so bearing is another power transmitting element and it is generally used for holding the shafts. So here you can see here bearing has two races. This is called as the inner race here, and what you see from here it is called as the outer race. So shaft is fixed onto this inner race like this, so it will be something like this. So still I can rotate the outer bearing. That means if I fix this, my shaft can rotate freely. So this is used for holding a shaft. So bearings are used as a supporting element for holding the shafts. Okay, so this is one example of power transmitting elements. Now power transmitting elements you can study, you will be studying in your theory classes also. Today we are going to see learn more about the gears. Okay, so gears, there is a wide classification of gears. One of the classifications of gears, it is based on the type of shafts on which they are fitted. Okay, now the two shafts, they may be parallel to each other, the two shafts may be in line with each other, the two shafts may be perpendicular to each other, or the two shafts may not be touching each other, or they may not be intersecting also with each other. Then they are called as skew shafts. Okay, they are neither parallel, they are neither perpendicular, they are neither in line or intersecting. These kind of shafts, they are called as skew shafts. Okay, now if the shafts are in line with each other, that means they are acting along the same line of action, then in that case clutch is one of the best way of using the best way of for transmitting power. Okay, or you can use flange, so gears are not required. Okay, in that case, now suppose if the shafts are parallel to each other, one shaft is at this position whereas another shaft is this at this location, and you have to transmit power from this shaft to this shaft, then you need gears. Then the type of gear which is used in that case, it is called as a spur gear. Okay, so this is a spur gear. This example which I have shown you earlier also, this is a spur gear. So in case of spur gear, you will see here these teeth, these are the teeth. These teeth are parallel to the shaft. So shaft will be here like this. Okay, so here you can see here shaft. So these teeth, they will be parallel to the shafts. This kind of gear, it is called as a spur gear. So I can show you an example of transmitting, how the power is transmitted. So you can see here in this example. Okay, so here you have another shaft. Okay, on which you have these two gears mounted here, and here you have one more shaft here on which here two gears are mounted. Now if I rotate one gear here, if I rotate one gear, the other gear also starts rotating. Now since these two shafts, they are parallel to each other, here we have used a spur gear. Okay, now in place of spur gear, you can have inclined teeth also, so it is called as a helical gear. Okay, so in case of helical gear, the teeth will be something like this. The teeth will be like this. So here you will be able to see now, this is the shaft which we have here. Okay, and these are the teeth. So these teeth, they are not parallel to the shaft axis, so but they are making some angle with the shaft axis. So the working principle in both the cases, spur gear and helical gear, it is same. The difference is that in case of helical gear, when the two gears, they are meshing with each other, these teeth, they come in gradual contact, whereas in case of spur gear, the whole length of the teeth comes into contact with the other gear immediately at one time. Okay, so here there is a gradual contact of teeth is there, and that is why helical gears, they are smooth in operation than the spur gears. Now we'll see one more example of gears. Now if the two gears, they are perpendicular to each other, so if the two shafts, they are perpendicular to each other, one shaft is like this whereas the another shaft is like this. Okay, then in that case you cannot use spur gear or you cannot use the helical gear, but what we are required to use there is the bevel gears. Okay, so bevel gears, this is the example of the bevel gear. Here you can see, I hope you can see the gears, two gears here. So you have one gear here, you have another gear here, and these two gears, they are meshing with each other. So this gear has the shaft like this, whereas this bigger gear which you see here, it has a shaft, vertical shaft like this. So these two shafts, they are perpendicular to each other. Okay, so this is called as a bevel gear. Now the third gear is called as the worm and worm wheel. Okay, now here you can see, this is the worm and worm wheel arrangement. Okay, so this is called as the worm wheel, whereas this is called as the worm. Worm is nothing but it is like a screw. Now and this worm is attached to this shaft. So this is the shaft which we have here. Now whenever it is required to reduce the speed of shaft, in a very large ratio. Okay, suppose 2000 rpm is there and it has to be reduced to simply 10 rpm, very low rpm. Then it is not possible to reduce the speed using this per gears or any other type of gears. So the best arrangement which can be done is using the worm gears. So here there is huge speed reduction is there. So this is called as the worm, and this is called as the worm, and this is called as the worm wheel. Okay. So this is worm and one wheel arrangement. Now our aim in this experiment is to find out the gear ratio or the speed ratio. Okay, that means if two gears are there meshing with each other, then what will be their speeds, how their speeds will change. Okay, that our aim is to find out that. Now let us see, here I have one example here. Okay, now in this particular example, here you can see this gear is very big in diameter. You can see the diameter of this, it's large, whereas this gear at the bottom, here you can see its diameter is less. Now if these two gears are mixing with each other, now if I rotate the small gear, isn't it, then obviously this larger gear will rotate at a smaller speed. Okay, it is revolutions per minute of this bigger gear will be lesser than the revolutions per minute of this smaller gear, that because of the diameter or because of the size of the two gears. Okay, so this is called, this is how the speed can be reduced or speed can be increased using the gears. Okay, now our aim is to find out the ratio. So obviously the ratio will be, the number of ratio will be equal to this number of teeth on this bigger gear divided by number of teeth on the smaller gear. That gives you the gear ratio, isn't it? So in this example again you can see here, suppose you have say 80 teeth are there on this bigger gear and you have 40 teeth on this smaller gear. So gear ratio will be 2:1, right? So obviously if the bigger gear rotates at 100 rpm, the smaller will rotate at 200 rpm, twice that. That means gear ratio is inversely proportional to the rpm or the speed, isn't it? So this is how we are going to determine the gear ratio or speed ratio also for gears. So I hope this is clear to everybody. I request you all to go through the lab manual so that you will learn more details about different power transmission elements also, and we'll have to solve one exercise which is given at the end of the your lab experiment. Okay, so wish you all the best and we'll see in the next practical.